Today we're going to learn about polynomial division, and we have three goals. The first goal is to apply integer long division to polynomials. The second goal is to determine a quotient using long division when we're given a factor for a higher order polynomial. Our third goal is to determine the factor form of a higher ordered polynomial. And our last goal is to find all the zeros of a higher order polynomial function. Before we start with our long division, we're going to quickly review how we find the zeros of a polynomial. And remember that when we're finding zeros of the polynomial, the number of zeros that we have depends upon what the power of the polynomial is. So on example A, we have an x squared. That means we're going to have two zeros. We have a trinomial here, and so to factor it, the first thing we do is look for a GCF, a common factor. There's not a common factor between 2x squared, 7x, and 6. So we're going to skip the common factor. And if the trinomial factors, it will factor down to a binomial times a binomial. To get 2x squared, we're going to put 2x and x in our first parentheses. And then we're going to find numbers that multiply to 6. And it can be 1 and 6, it can be 3 and 2, it can be, we can reverse them, 6 and 1 and 2 and 3. We don't know, but we're going to plug them in and then multiply and find out which one works to give us the minus 7x plus 6. We do know that what we put into the parentheses cannot have a factor in common with what's already in the parentheses. So I can't put a 2 here. And I can't put a 6 here because they would have that 2 in common. So I want to start by checking, let's put the 3 and the 2 in. And then we're going to multiply it out. This is 2x squared. Here's 4x. Here's 3x. And 3 times 2 is 6. So I need to make this negative 7x. So if I make the 4 and the 3 both negative, so that means put minus signs up in our parentheses, and negative 3 times negative 2 is a positive 6, then we get our factoring correct. And once we have it factored, now we can find our zeros by setting our function equal to 0, and then all of our factors equal to 0, and solving for x. So in our first one, we're going to add 3 over, so we have 2x equals 3, and then divide by 2. And so I get x is equal to 3/2. And in the second one, we're going to add the 2, and we get x equals 2. And so those are the two zeros. And again, we knew we were looking for two zeros because it was an x squared. In example 3, we're looking for, or in example B, we are looking for 3 zeros because it said x to the third. So we're going to keep that in mind. And we can see we have 1, 2, 3, 4 terms in our polynomial. So we're going to use our polynomial factoring that we learned in our last lesson, lesson 4.1. And that focuses on that distributed process that we just went through in example A. So we're going to set up our parenthesis times parenthesis, our binomial times a binomial. And to get x to the third, we're going to throw in an x squared and an x. Our next term is 1x squared. So when we multiply x squared times x, there's x to the third. And x squared times something has to give us 1x squared. Well, it's plus 1. And then our next term is a minus 2x squared. Well, here is the x, so this has to be a minus 2 to get a minus 2x squared. And then the minus 2 times a 1 is minus 2, and so we know that our factoring is correct. So let's get rid of these lines. And now that we have the correct factoring done, we can set it equal to 0, and then set each factor equal to 0 to come up with our solutions, our zeros. So we're going to add 2 over. We get x squared equals 2. And then we're going to take the square root to undo the x squared. And whenever you take the square root when you're solving, you're going to put positive and negative. So we get a positive square root of 2 and a negative square root of 2. And then our last zero, x plus 1 equals 0, we're going to subtract our 1. And we end up with a negative 1. And so these are the three zeros because we have third degree, we get 3, 0, everything matches up. In example C, we have a third degree polynomial just like we did in example B, and we have those 4 terms just like we did in example B. So let's try our strategy, our factoring technique that we did in example B, where we set up our parenthesis times parenthesis. And to get x to the third, we're going to put x squared and x. Our next term is minus 9x squared, so here's the x squared. It means we're going to have a minus 9 here. And then we needed a plus 8x, so here's the x. We're going to put plus 8. And then we got to check to see if we get 60. So 8 times negative 9, it's not 60. That means that this polynomial factoring did not work with any of the factoring tools that we know. So does this polynomial work? No, it doesn't. How can I find the zeros? Well, that is why we're having this lesson today. We need another tool for our bag of tricks. So when we start factoring polynomials, that's the same thing as dividing or breaking apart the polynomials. And so if something doesn't factor with a way that we know how, we need another process. And that process is long division. And it's very, very similar to the process that we use to long divide our whole numbers that we learned clear back in elementary school. And so we have to review some division terms. This is how we would set up a long division problem. And our divisor, that's what we're dividing by, goes outside of the long division bars. And then our dividend, that's what we are dividing, goes underneath. And our answer is called our quotient, and it goes on top of the long division bars. And so if we're dividing, in example 3, 546 by 13, 13 is our divisor. So we would do 13 divided into, and 546 is our dividend. And then we can start our process to come up with our quotient. And so we would say, okay, 13 goes into 5. Oh, it doesn't go into 5, so now we need to go to 54. And 13 goes into 54 4 times. And then I multiply down. 4 times 13 is 52. And then I subtract. So 54 minus 52 is 2. And then I would say 13 goes into 2. Oh, it doesn't go into 2, so I would bring down my 6. And then I would say 13 goes into 26 2 times. And then I would multiply. The 2 times 13 is 26. I subtract, and I get 0. When I get 0, that means I don't have a remainder. It means that it divided evenly. And it means that the divisor times the quotient is equal to the dividend. And so in this case, the 13 times the 42 is equal to the dividend, which is 546. And understanding that will become critical when we start dividing with polynomials. So dividing with polynomials, we're going to set it up just like we did our integer example on the previous problem. So we're told that x minus 5 is a factor. Now, if it is a factor, that means we know right off of the bat that it will divide evenly. Okay, and so we're going to use that fact and get this function, f of x, into factor form and then find the zeros. So we'll do x minus 5 divided into x to the third minus 9x squared plus 8x plus 60. And when we start the process, we're just going to start looking at this x. And we're going to say x times something will be x to the third. Or we can think of it as x goes into x to the third how many times? Well, it goes x squared, because x squared times x is x to the third. And then we're going to multiply the x squared through the divisor. So I have x squared times x is x to the third, and then x squared times a minus 5 is minus 5x squared. And then just like in our integer example, we subtracted, we're going to subtract here. So we have to be careful when we subtract a polynomial that we subtract on each of the set of like terms. So we're going to do x to the third minus x to the third. X to the third minus x to the third cancels. And then we're going to do negative 9 minus the negative 5. Well, minusing a negative 5 is this, the two negatives will cancel, and so it becomes plus. And so a negative 9 plus 5 is a negative 4x squared. Another way of dealing with those subtractions, subtracting polynomials, is the same thing as adding the opposites. So we're going to change it to add and then the opposites of these signs. And then our next step, we're going to bring down our next term, just like we did with our integer division. And then we repeat this process. And we start by saying x goes into negative 4x squared how many times, or what times x will give me the negative 4x squared? Oh, a negative 4x. And then we're going to distribute. Negative 4x times x is minus 4x squared. Negative 4x times a negative 5 is plus 20x. And then we're going to subtract, which is the same thing as adding the opposite. So we add and then change your signs. So negative 4x squared plus 4x squared cancels. 8x plus negative 20x is negative 12x. And then we're going to bring down our next term, which is plus 60. And then we repeat this process. And we are going to say x times what will give me negative 12x. Oh, negative 12 is what I'm going to put up here, and then distribute. Negative 12 times x is negative 12x. Negative 12 times negative 5 is a positive 60. And then we're going to subtract, which is the same as adding the opposites. So I changed their signs. And negative 12x plus 12x cancels. 60 plus negative 60 is 0. We got 0 because it was a factor. We knew it would divide in evenly. But more importantly, we now broke apart f of x. And we know f of x is equal to the divisor, which is x minus 5, times the quotient that we just found, which is x squared minus 4x minus 12. And we started this factoring process. So the next thing to do is to look at this quotient and see if it will factor further. Well, it's a trinomial with x squared, so if it factors, it will factor down to a binomial times a binomial, x times x. And then I'm looking for numbers that are going to multiply to negative 12 and add to negative 4. So I know I have a negative 6 plus 2, because here's 2x, here's minus 6x, which is that negative 4x, and then negative 6 and times 2 is negative 12. So that is now factored. The quotient is now factored. We have our original divisor, and now we can set it equal to 0 to find the zeros of the polynomial. So our zeros, remember our little shortcut, we can do just the opposite sign. We're going to get 5, 6, and negative 2. We got 3 zeros because it was a third degree polynomial up here, so we needed to find 3 zeros. In example number 5, we're going to step up the level of difficulty, and this time we are given an x to the fourth. That means we have to come up with 4 zeros. We've never factored anything with x to the fourth or with anything that has 5 terms in it. So this is where polynomial division is going to help us start the factoring process. We're told that x plus 2 is a factor, so it's going to divide evenly. So we're going to set up our long division. So we have x plus 2 divided into x to the fourth minus x to the third minus 7x squared plus x plus 6. And then we start the process. X times what will give me x to the fourth? Oh, that's x to the third. and then we distribute down through the divisor. So x to the third times x is x to the fourth, x to the third times 2 is plus 2x to the third. And then we subtract, which, remember, is the same as adding the opposite. So we're going to add and change their signs. X to the fourth minus x to the fourth cancels. Negative x to the third minus 2x to the third is negative 3x to the third. And then we're going to bring down our next term, minus 7x squared, and then repeat the process. So x times what will give me negative 3x to the third? Negative 3x squared. Distribute down through the divisor, so I have negative 3x squared times x is negative 3x to the third. Negative 3x squared times 2 is minus 6x squared. And then we're going to change the signs and add to accomplish that subtracting. So negative 3 plus 3x to the third will cancel. Negative 7x squared plus 6x squared is negative 1x squared. And then we're going to bring down our next term, so plus x, and now repeat again. And so we're going to say x times what will give us negative x squared, a negative x, and distribute down, so negative x times x is negative x squared. Negative x times 2 is a minus 2x. And then we're going to change our signs and add. And so negative x squared plus x squared cancels. 1x plus 2x is 3x. And then we're going to bring down our last term, which is a plus 6. And then we'll go through the process for the final time. And we have x times what will give me 3x? 3. And then distribute down. 3 times x is 3x. 3 times 2 is plus 6. And when we subtract 3x plus 6, from 3x plus 6, we get 0. Or we can change our signs and add. Either way, we get 0. More importantly, that started the breaking down process of our polynomial. We now know that the divisor, which was x plus 2, times the quotient we just found, which is x to the third minus 3x squared minus x plus 3, is equal to that original function if I multiply those together. Now I want to factor further so I can find all of the zeros. So if this x to the third, the quotient, x to the third minus 3x squared minus x plus 3 factors, we're going to try our new factoring technique that we learned in lesson 4.1. To get x to the third, we're going to do x squared and x. Our next term is minus 3x squared, so here's the x squared. That means this is a minus 3. Our next term is minus x. Here's the x, so I need a minus 1. And then a minus 1 times a minus 3 is plus 3, like the quotient has. So there is my factoring along with my divisor, x plus 2. Now I can set it equal to 0 to find all of my zeros. So my first factor, x plus 2, will give me a 0 of negative 2. My last factor, which is x minus 3, will give me a 0 of 3. But this x squared plus 1 needs a little bit of work. It can factor further because it's a difference of squares. So it will factor down to conjugates, x plus 1, x minus 1, which means that my last two zeros are negative 1 and a positive 1. We got 4 zeros for an x to the fourth power, so that makes sense. Okay, our last example that we're going to look at, sometimes our dividends can have missing powers in them. So if you look at example number 6, we have an x to the fourth and then an x squared. It's missing an x to the third. Where is it at? And it's missing an x. Where is it at? Those are missing. And so to make our long division easier, we have two choices. We can either leave gaps in our problem, or we can simply include the missing terms with a coefficient of 0 in it. That is what I recommend doing. if we put those missing terms in with a coefficient of 0, so we're going to add in 0x to the third, and we're going to add in 0x. And so all powers of x are now accounted for in the dividend. What this does for us is it just creates a problem that's more organized, where all of the like terms will now line up when we do our long division process. So setting up our long division, the x minus 2 is a factor, so we're going to divide that into our f of x with those 0 coefficient terms added in. So we have x to the fourth plus 0x to the third plus 5x squared plus 0x minus 36. And now we can start the process. X times what will give me x to the fourth? Oh, x to the third. And then we distribute down. X to the third times x is x to the fourth. X to the third times minus 2 is minus 2x to the third. And then we subtract, which is changing their signs and adding. So x to the fourth minus x to the fourth gone. And 0x to the third plus 2x to the third. Notice by having that 0x to the third, these are like terms that are going to line up. Without the 0x to the third, you would not have like terms to line up with. And so that's why it just organizes it and simplifies the process a little bit. So we're going to now bring down our plus 5x squared and repeat. X times what will give us 2x to the third? Oh, 2x squared. Multiply down. 2x squared times x is 2x to the third. 2x squared times a minus 2 is minus 4x squared. And now we change our signs and add. So 2 minus 2 is gone, and 5x squared plus 4x squared is 9x squared. And then we're going to bring down the 0x and repeat our process. And so we're going to say x times what will give us 9x squared? Oh, that's 9x. And distribute down. 9x times x is 9x squared. 9x times a minus 2 is minus 18x. And then we subtract, which is changing their signs and adding. 9 minus 9 is gone. 0 plus 18x is 18x. And then we're going to bring down our last term, which is a minus 36. Repeat the process for a final time. X times what will give us 18x? 18. And then distribute down. 18 times x is 18x. 18 times a minus 2 is minus 36. And we're going to subtract, which is changing their signs and adding, and we get 0. We knew we would get 0 because we were told that x minus 2 was a factor. More importantly, excuse me, more importantly, we now know that the divisor x minus 2 times our quotient, which is x to the third plus 2x squared plus 9x is equal to that dividend f of x. And it started the factoring process. Our next step is to factor the quotient further if we can. So the x to the third, we're going to try our technique that we learned in 4.1. To get x to the third, we're going to have our two parentheses. X squared times x will give me the x to the third. My next term is plus 2x squared. So I have x squared. I need 2x squared, so plus 2. My next term is 9x. So here's the x. We're going to put a plus 9 in there. And then the 9 times 2 gives me 18. And so I have what the quotient was. So I know my factoring is correct. Okay, then we're going to look and see if we can factor anything else. X minus 2 does not factor further. X squared plus 9. Because it's a plus sign, it won't factor further. And then the x plus 2 does not factor either. So I can set it equal to 0. And now I can come up with my solutions, my zeros. So I have x minus 2 equals 0. I have x squared plus 9 equals 0. And then I would have x plus 2 equals 0. So on the first one, we're going to add 2 and get x equals 2. And I'm going to do the last one, minus 2, to get x equals negative 2. So we're going to add that to our list here. This one, let's see if I can give myself a little bit more room. X squared plus 9 equals 0. I'm going to minus the 9 over, so I get x squared equals negative 9. And then I would take the square root to solve. And when I take the square root, I have to put positive and negative, and then I have a square root of a negative. That means I have an imaginary number. And the square root of 9 is 3, so it becomes positive and negative 3i. So adding those numbers to our list, we have a positive 3i and a negative 3i, and I have 4 zeros to match my 4th degree polynomial that I was given in the first place.